The software release process is a barrier between written code and a live production environment that affects users. A software release process can involve a variety of different practices. Code might be tested for bugs using automation and manual testing. Static analysis tools can look at the code for potential memory leaks. A software release might go out to a small percentage of the total user base before it gets deployed to the entire audience. At some organizations, a software release can be slow and painful. The release might be bottlenecked by a manual approval step, which slows down developers from quickly deploying their own changes. If a consistent version history of software is not maintained, a release can be hard to roll back in the event of an error. In the case of a large monolithic architecture, a release can be scary because it can be hard to understand how the monolithic codebase functions. This set of challenges within the release process can lower the quality of software and make it frustrating to build software. The release process is just one area of software development that many organizations have a desire to smooth out. Over the past 10 years, a set of technologies and philosophies have provided improvements to the software development process. DevOps, continuous delivery, microservices, cloud providers, and serverless tools all make it easier for a company to focus on its core competency and release software faster. Baruch Sadogursky is an author of Liquid Software, a book about continuous updates and DevOps. Liquid Software defines an idealized vision of what today's architectures could aspire to. The focus of the book is continuous updates, which allow for rapidly improving, evolving software quality. Baruch joins the show to discuss how software has changed in the last 20 years and how the future of software development could look. Full disclosure, Baruch works at JFrog, which is a sponsor of Software Engineering Daily. Fission is an open-source Kubernetes native serverless framework. Fission allows you to easily code serverless functions in any language and have them run wherever you have a Kubernetes cluster, be it in the public cloud, in your own data center, or even on your own laptop. Fission automatically manages the infrastructure for you, so there's no need for any in-depth knowledge of Kubernetes, no containers to build or registries to be managed. With Fission, you can essentially run your own Lambda-like service, benefiting from the speed and the cost savings of serverless on any environment. Go to fission.io to get started. You can use Fission to create serverless API backends, implement webhooks, create event handlers, and more, all without having to bother with managing infrastructure, let alone Kubernetes at scale. To learn more about Fission and to try it out, go to fission.io. Baruch Sadogursky, you are the head of developer relations at JFrog. Welcome to Software Engineering Daily.
Thank you. Thank you for having me. It's a great honor and pleasure. That's one of the biggest and the main podcasts in the industry, and I'm really humbled and happy to be here.
Well, thanks for the compliment. So you're also the author of Liquid Software, and that's what we're going to be talking about today. So your book, Liquid Software, it starts by presenting the idea of liquid software. What is liquid software?
Yeah, so I'm a co-author, and the main, I would say, two authors behind the idea are two of the co-founders of JFrog, Fred Simon and Yoav Landman. And again, I was just lucky to be around them in the right time, so this is how I shared the stage with them a little bit. The idea of liquid software is about, I would say, the next change in how we deliver software in our industry, and the vision behind it is that we will deliver our software so frequently and in such smaller packages or batches or pieces that it will look like a flow of software. That's the idea of the analogy.
So that sounds desirable to most people listening to the show, because the idea of liquid software model where software is flowing out from the provider of that software easily to the users, to the people that are consuming it. It sounds a lot like a highly optimized continuous delivery model. It sounds like fixing software would be easy, like releasing software might be easy. And so there's a lot of different areas that you touch on in the book that compose this overall, I would say, optimal vision for how your software should be released and how it should be built, this liquid software ideal. But I'd like to break down some of these individual categories that compose the idea of liquid software. So if we talk about a large established enterprise that has been around for a long time, and we compare the software architecture of that large enterprise with all its legacy software, it's got legacy mobile applications, it's got internal CMS systems that maybe are proprietary, and we compare that to a brand new startup that was maybe created in the last year, maybe it's entirely on the cloud, their release process is super fast and decoupled. What are the things that the startup might be doing or that the startup can do because they are cloud native, because they came out later in the game? What are the things that the startup can do that are not as easy for the established enterprise with lots of legacy software to achieve?
I would say that obviously the main difference is that this enterprise carries over a lot of legacy technical debt. And the real problem with that is that when you do something new and you start from scratch, it's much easier to do the right thing. Also, might be a lot of software and a lot of technology in those bigger enterprises, which are not the core of what enterprises is good at and what they are doing. All those, internal homegrown CRMs and ERP systems, all those back office systems, which are obviously not what the enterprise is selling or not what the enterprise core competitors is. And that's, of course, gets much less attention and much less budget and funding and much less resources. So it's much harder to change. And I think that the startup, and startup should be, the agility is what makes the difference, and being able to do the right thing from scratch. Saying that, I not claim that change in larger enterprises is impossible. We have some nice examples of enterprises which we consider very old school and very slow, actually manage to adapt to new ways and new paradigms successfully. It's just harder when you have a lot of legacy stuff.
Definitely. So I've my biggest touch point for these legacy enterprises, and I almost don't like calling them legacy enterprises because a lot of them are still very much in our everyday lives today. They are not legacies, but I've seen the struggles from them. I talked to a lot of them when I went to the DevOps Enterprise Summit a couple of years ago, and there's just a lot of companies, insurance companies, banks, agricultural technology companies that have been around for 20, 30, 50, 80 years, and they just have so much software, and they have more software than they have developers to work on it, and there's things in the corner that nobody knows how it works, but it still works, and so they leave it there because it's stable. But you said you have seen some proof points for these kinds of companies that have managed to modernize and become much more agile. Can you tell me more about those examples, or at least tell me who the success stories, or what those success stories, what are they doing right that allows them to move more quickly?
Yeah, of course. One of the examples I'm talking about banking industry for me is Capital One, which for me they do amazing job in adjusting to those new patterns and new paradigms, I would say. And I guess the difference is you need to know what to do. You need to believe that your organization is capable of taking this journey, and someone needs to care and actually move the thing forward. If you have all three of those components, you know what to do, and you think that you are capable of doing it, and then there is someone who actually drives it, you can do it.
I agree. Capital One's done they've made a lot of progress, and you see them at conferences, you see them presenting about some of the changes they've made, and it sounds a lot like the same kinds of recommendations that you hear from people that have done lots of refactoring in this space or that have modernized their enterprises, but it's clear that they've executed on a lot of things. So one thing that I see has happened in the last 10 years or so is that the purchasing patterns of software, particularly software that's sold to the enterprise, has moved from a model of that is very illiquid, for to use your terminology, where, for example, if I'm selling to an enterprise, maybe I'm selling you this big chunky piece of hardware, or I'm selling you software that's got a yearly subscription or a 5-year subscription model, and you feel locked in and you have to pay a lot of money. It's kind of gone from that to more of a SaaS offering. You're paying over time. It's easier to purchase. It's easier to come on board and to leave eventually. And I think it's raised the expectations for what people want out of software, and also it's given them more flexibility. So how has the SaaS model and the cloud model changed the relationship and the expectations between vendors and the engineering orgs that are buying from those vendors?
Yeah, you're absolutely right. And we're here getting close to the need for liquid software. Why would actually an organization feel that they need to adopt something like that? And generally, all the concept of small startup disrupting those markets and the cloud as well, the subscription model and the I would say hatred in the industry towards lock-in and the effort of having something standardized or something that is easy to walk away from is actually one of the reasons why we feel liquid software is something that will become more and more important, because now it's all about beating your competition to market and providing more value and more quality than the other company that you compete with. And when we are talking about being faster with better solution to market, that's exactly what liquid software comes to provide.
So the people that are listening are probably motivated to move towards this liquid software delivery model. They probably also heard of other terms that are related to this kind of concept. They've heard of continuous delivery. They've heard of DevOps. Is the idea of liquid software, is that complementary to these other paradigms? Is it completely different? How does liquid software compare to these other popular software modernization paradigms?
So liquid software is the idea that you release extremely often. It's actually, you have a constant flow of changes from the development into the end device, whatever it is, being it a server in your data center, being it a server or on a cloud, or being it a device that you hold on your hand, or a smart bulb at your home. It's just a concept of delivering faster. And the way to do it is actually come from this idea of what we have now technically, right? So if we have continuous delivery, will it serve liquid software? Can you do liquid software with continuous delivery? We have manual QA. Can you do liquid software with manual QA? Or there is need for something else?
So liquid software, to me, it sounds like the ideal. So it's like an ideal that you're going for. Maybe you can get there, maybe not, but it's an ideal that we can establish is desirable.
Yes, and we believe that we definitely can get into that, and for that we might need new implementation paradigms. And this is where the other concept of the liquid software book comes into play, and that's continuous updates. Continuous updates for us is the mean to get to liquid software. Maybe not the only one, but this is kind of the one that we feel can bring us to liquid software on a shorter path.
That term continuous updates, that sounds like continuous delivery or continuous deployments or continuous integration. What is continuous updates?
Yeah, so continuous updates is definitely from the same family of continuous things. And I would say the main difference from continuous deployment is that we realize in continuous updates that most of the software provisioning that we do is actually an update of an existing system with existing state, with existing data, with existing requests in flight, and we make an update of this software and not necessarily recreating the software from scratch as we used to do now with continuous deployment and continuous delivery. Does it make sense?
So are you saying that in contrast to today's model where you are throwing away the old immutable infrastructure and replacing it with a new version, you're saying that continuous updates, it might be advocating for a modification to the version that's already deployed?
And this comes from the fact that we want to push very, very small pieces of software to those end devices. When we talk about, okay, let's just nuke everything and set up everything from scratch, it kind of implies that we are going to replace one big thing, whatever we have right now, with another big thing, whatever we have right now. And this implies that we still will push relatively big packages on trucks instead of sending liquid software on pipes. That's kind of the picture that I have in mind. And if we do liquid software, if we do push very tiny pieces of software, that means that we are going to change only tiny pieces of our system every time. And this is much more an update process than of replacing process.
Right. So this sounds kind of like how many people envision the world turning out with functions as a service being the composable unit that you build your software out of, and you kind of fit your software together around functions as a service and maybe some managed services that you might buy from a cloud provider, or things that are coming from proprietary software, like proprietary software running on your iPhone. But in general, the deployable unit, the composable unit, is a function. Do you see that as one side of the liquid software vision, this function as a service composable unit?
Oh, absolutely. All the movement towards minimization of software units is going straight into this paradigm of liquid software. When we moved from a monolith to microservices, when we moved from huge Docker images to those tiny distro-less Docker containers, and when we move into the serverless function-centric pieces of software, that's exactly that. We're going smaller and smaller, and we should be able to deliver all those pieces faster and faster.
Today's episode of Software Engineering Daily is sponsored by Datadog, a monitoring platform for cloud-scale infrastructure and applications. Datadog provides dashboarding, alerting, application performance monitoring, and log management in one tightly integrated platform so you can get end-to-end visibility quickly. And it integrates seamlessly with AWS so you can start monitoring EC2, RDS, ECS, and all of your other AWS services in minutes. Visualize key metrics, set alerts to identify anomalies, and collaborate with your team to troubleshoot and fix issues fast. Try it yourself by starting a free 14-day trial today. Listeners of this podcast will also receive a free Datadog t-shirt. Go to softwareengineeringdaily.com/Datadog to get that t-shirt. That's softwareengineeringdaily.com/Datadog. There are a couple engineers I've talked to at major internet companies who have said recently that there is maybe an over-aggressive move towards breaking down the monolith. So some of the most highly regarded engineering organizations like Facebook and Google, I know to some degree manage their software as a mono repo. It's not exactly it's not a monolith, but it's a mono repo. And I've heard that there is some simplicity that can be gained through having some centralization of infrastructure. Have you talked to anybody who is advocating for more monolithic, more centralization? Is there a counter argument that you hold in esteem?
Yeah, so monorepo is, as you mentioned, not exactly monolith. And of course, microservices bring an enormous complexity into the system, especially when we are talking about interoperability between the microservices when they are on different versions, and especially when data is involved, which might be on different versions as well. And monolith doesn't have that problem. It has a bunch of other problems, but not this one. And having a mono repo is one thing, and delivering software in smaller pieces, it's another. It is harder to do the right thing when you need to send smaller chunks of software constantly, and of course there are issues with how to update properly, how to roll back properly, how to build those updates to be transparent to the users, and of course, just declaring, okay, continuous update, and that just happened. This is not realistic. Our book, among other things, go into good level of detalization and good amount of helpful tips about how to manage this complexity that comes with constantly updating different parts of your software.
Right. So in speaking about those different parts of a software infrastructure at a legacy enterprise, I think a legacy enterprise is generally not looking at things the same way that a Google or a Facebook could, because a Google or a Facebook has effectively unlimited engineering resources. Not truly unlimited engineering resources, but a legacy enterprise is more like they've got some engineers, the engineers are specialized in certain things, maybe some of them are highly specialized in how to operate some older systems, and so you're not dealing with the same kind of engineering workforce, and so you don't exactly have the same capability of just moving your architecture in whatever direction you want to. You are kind of restrained by the legacy of what applications you have around. You have this proprietary CMS, you've got maybe you're operating out of an on-prem data center, and that's that's just the way things are. You're not going to be able to throw away that and move to the cloud instantly. And you've got all these different things. You've got mobile apps, you've got internal web apps, you've got legacy dashboards. So for somebody who's in an enterprise like this, or who has just entered an enterprise, like maybe somebody listening is a new grad and they've just entered into an insurance company and they're doing technology in an insurance company that's 80 years old and they have no idea how to handle this modernization process. It can be really intimidating. What are some general principles for how to approach this wide array of software that is not getting released as easily? The rollout process is not as smooth. There's a lot of pain. What are some general things to keep in mind to make steady progress in making that software more liquid?
So I think we need to keep in mind what is the goal of going liquid. And what we try to do is actually release faster, more and more reliable, and with higher quality. And it is a trade-off like everything in life. When you have some back office application that is used once a month and generally does its job pretty well and gets updated 1 in 3 years, I'm not sure if that's your next migration to the liquid software should be. Right, because it's all a matter of, as you mentioned, there is finite amount of engineering force that really need to do the right thing, and I'm not sure this is the first thing that they should invest in.
So what's the prioritization process? I'm the CTO, I'm looking out at, a vast quantity of things that I could refactor, and I've got a feature backlog of 10,000 different things that the product management team wants me to implement. How do I direct my engineering resources?
So I truly believe that everything starts with the business value. This is why we are in the industry. Eventually someone pays our salaries, and those salaries come from the profits of our organization. So if we're talking about deciding where should the effort come first, I would say we need to check the impact on the overall business of the organization. And if we're talking about banking industry, for example, I'll tell you a story. I switched banks over usability of a mobile app. And I cannot say that I'm the most important customer of my bank, but I think one bank lost a pretty decent customer and another gained just because their mobile app allowed me to do more when I am on the road, which is unfortunately most of the time. So this is right there is a business value, and maybe investing in beating our competition into the market of mobile apps, or having a better web application, or delivering more functionality at the ATMs. Can I don't know, do stuff, deposit cash? I can deposit cash in any ATM in one bank, and I cannot do it in the other bank. Here we go. That's the value that worth investing. And if I can do it, if I can beat my competition, or at least catch up with my competition much faster than others, I am in a better place in terms of providing more value to the business.
It's such a good point. By the way, I have switched banks for the exact same reason. It's terrifying. Like, how can you think that your terrible mobile application is doing the job? I've seen like this bank that I used didn't update their mobile banking software for the entire time that I was a customer there, and it was one of these terrible cross-platform implementations that it's the exact same on Android and iOS, and it's just terrible all around. And anyway.
Yeah, no, but I mean, and here we can start to speculate why that happened. And things which are not of our control is just bad product management. Maybe someone just thinks that mobile app still doesn't matter. And you know what? And they will tell you, what's the problem? You can always go to our branch, which is open 10 to 4, 3 days a week, right, and do whatever you need to do. Those hipsterish apps, no one uses them. And this is something that obviously we cannot help. But we can speculate that the problem is technical, and this is where we're like, yeah, we can fix it. And of course, okay, so it comes from the code base, which is produces a monolith, and they don't have effective pipelines, and they do a half a year release process with manual QA and what's not, and it holds them behind. So actually they do want to move forward, but they can't, and this is where modern paradigms like Liquid Software, like continuous updates can help.
Well, and this also ties in with what you said about the importance of the engineering workforce knowing the business. So I think there's a lot of different decisions that engineers make that are going to directly impact the business. And if the engineers don't understand the business, they're not going to be able to vet those decisions. They're just going to kind of take the orders from that they're handed by their manager, and the manager might know a little bit more about the business than them, but that doesn't mean that if I'm a random software engineer working on a team, I can't make a decision that is not going to be informed by some business value. And I think this is something that you kind of also see in the DevOps world, the emphasis on breaking down silos. DevOps is not actually just about breaking silos between development and operations. It's also breaking all the other silos, like between business understanding and engineering understanding. If you're an engineer and you want to move up in the world, you better learn about the business that you're working at, because you're going to be in charge of making architectural decisions, increasingly buying decisions, and all of these things are and that's probably the kind of thing that has fallen through the cracks at your and my banks that have not developed a good mobile banking software, because the engineers that are working there are not thinking about the business, or they're not thinking about the business in the right way. And so they're not making the right engineering decisions that would fall from thinking about the business.
Yeah, absolutely. And this is also something, and the DevOps concept ties directly back to Liquid Software. And that's kind of another, I would say, requirement, because Liquid Software in an organization actually involves everybody in this streamlining process, because otherwise those silos will prevent software from flowing.
Right. So that dovetails nicely into the idea of releases. So if I'm at one of these enterprises, there can be a lot of barriers to getting my software out quickly. There's different review processes, there's red tape, there might be manual testing that has to occur before, even once I get the software developed and I'm in the process of releasing it, there's manual testing, probably more manual testing than there is automated testing. You also might have manual security checks. Maybe you have to get your users to sign some kind of agreement that gives you permission to roll out this new piece of software. How do you overcome these different bottlenecks, the human bottlenecks in the release process?
Yeah, I think you touched here on one of the most important barriers to the adoption of liquid software, and that's quality, quality of the software, which actually introduces barriers from both sides, both from a side of producing the software, but also from the side of consuming the software. And I think I will start with later just because it's solved with the same solution. So one of the reasons why a customer might not want to get into liquid software is the acceptance, the trust in your software to provide smooth acceptance. And I can give you an example, for example, of Java releases. As you know, they recently moved to a very rigid 6-month release cycles, in which they actually say, no matter what, every 6 months you will get a new version of Java. And I just came back from a conference formerly known as Java 1, now called Oracle Code 1, and we do one of the talks that we kind of do there for many years is Java puzzlers, and just funny puzzling questions about Java. People have no idea what's going on. And the first question that we ask is, which version Java are you on? So I think except of one person, and we had, I would say, like 100 people in the crowd, except of one person, which basically means 99%, are using Java 8
Java
today.
6. Oh, Java 8.
Java 8.
Okay.
Java 8.
All right.
Everybody are on Java 8, 99%. And Java 8 was the last released in an old cadence, and no one updated to Java 9 or Java 10, which are, I would say, not major releases. They are major, but they are not long-term support releases. But also no one actually moved to the long-term support release, Java 11, which supposed to be a reliable and kind of a good release to update to. You might say, okay, this Java 9 and 10, those hipsterish frequent updates are not for me. I'm like a huge enterprise and I don't take the JDK updates lightly. I want to test them and everything, but they are not on 11 as well, which kind of makes me worry. And getting back to my previous phrase, we are not ready to get those updates. We cannot take those updates lightly is about trust. What those customers say to Oracle is, we don't trust the JDK and we need to perform a lot of work in order to take this update. We actually have to run rigorous tests in order to verify what you are telling us, and that's that your software is good and there are no bugs and you can upgrade. And this is the problem of accepting liquid software, because now if I'm a software vendor and let's say we do Artifactory and X-Ray and Enterprise Plus, and we come to a customer and we say, okay, now we want to push updates into your Artifactory instance on a liquid basis, you won't even know. You will just always be on the last update. And what we actually say is that every commit that our engineers in JFrog R&D will end up in your production environment with your production Artifactory in a matter of minutes. We might hear, you know what, guys? No. We cannot do that. We need a numbered release that we can download, install on a staging environment, kind of test against it very rigorously, and only then we'll take to production. What our customers actually tell us in this scenario is, we don't trust you. We don't trust that your liquid software, your continuous updates are tested enough for us to accept. And this is the barrier to acceptance from the customer perspective. And we have it not only in software vendors, but we also have it with everything. And now you remember how you eagerly downloaded any update of Mac OS operating system?
Not anymore.
Not anymore, exactly. Right, so there is, and why? Because you did it and it broke things. And you did it again and it broke things again. And now you just don't trust, right? The same with your phone operating system updates, the same with other software. You go now to present on a conference and you have this pop-up of Microsoft, do you want to update your PowerPoint? And you're like, no,
God, no.
I have a presentation tomorrow, no updates. So, and this is it. We have an issue of trust. And it is the same issue that prevents the vendors from implementing Liquid software. They are saying the same thing. We have to have manual QA because we want to release software that our customers will more or less trust. More or less because we know they will do the acceptance test because they still won't trust us, but at least we'll do something better. And this have only one solution. And the solution, as weird as it may sound, is actually releasing more and releasing faster. Because if it is painful, do it more. We do it in gym, we should do it at work as well. When we automate, when we repeat, when we continuously improve, we will get better. And it's not just, kind of ideal hippie-ish mantra. We actually have proof. And the most profound proof is latest Accelerate State of DevOps report from DORA Institute. And that's a report by Dr. Nicole Forsgren, Jez Humble, and Gene Keen, which all of them are obviously people that we know and trust. And they issue this report, the State of DevOps report, every year. And in the latest edition, which was released, I think, a couple of months ago, there is very profound finding. And this finding is not only there is no reverse correlation between the frequency of releases and quality, there is a direct correlation between the frequency of releases and quality. The more you release, the higher your quality gets.
That is very well said. And if you think about it, some examples of frequent releases where the software just improves over time and there's no manual updates. So EC2, for example, as far as I know, you don't have to manually update it. Like, it just gets patched for you. Or, if not EC2, like I haven't spun up an EC2 instance in a while. I've never managed a big EC2 set of instances, but like ECS or Amazon's AWS Lambda API, or if I'm using my Google Home, I have no idea what version my Google Home is on, but it always gets better. And when it gets worse, it gets better in a couple days. Like, they figure it out because they have good observability around, user sessions, and they can detect anomalies. And if a user stops using it, they know, okay, we rolled out something that was erroneous. And so they just push it out to you because they know it's an improvement. It's not like the iOS operating system where, it's kind of an improvement, but actually it drains your battery life twice as fast. And because they want to put the onus on the user in that case to install this software that bricks your phone.
So all those are exactly the examples of Liquid software, or at least getting that. And I was very puzzled with this anomaly. How comes that when you remove manual QA, you actually get better quality? And in this report, in the DORA State of DevOps report, there is a great diagram that now goes directly into all of my content, which is called the J-curve of transformation. And on this J-curve, there are number of states. First of all, team begin transformation and identify quick wins, and they move towards Liquid software and faster development cycles. And then automation helps to actually go faster, but then quality plummets because suddenly we do less manual checks. And we realize that we start automating it, and we can actually get better quality by performing better automated checks, which will run faster. So that means that we can do more of them, and this is how we provide better quality. And this is J-curves on transformation is very powerful. It makes a lot of sense. It is proven, and it is actually the answer of this problem of trust. And obviously, we need different levels of trust. You need different levels of trust for your Google Home Assistant and network of ATMs, obviously. But eventually, It's the same. The tolerance for failure is less. Our ability to perform rollback or patch is obviously need to increase when we need to update an in vehicle in motion or a plane, but eventually the concepts are the same. Build a pipeline that you and the end user trust and incorporate in it facilities for rollback, and this is how you move forward.
Failure is unpredictable. You don't know when your system will break, but you know it will happen. Gremlin prepares for these outages. Gremlin provides resilience as a service using chaos engineering techniques pioneered at Netflix and Amazon. Prepare your team for disaster by proactively testing failure scenarios. Max out CPU, black hole, or slow down network traffic to a dependency. Terminate processes and hosts. Each of these shows how your system reacts, allowing you to harden things before a production incident. Check out Gremlin and get a free demo by going to gremlin.com/sedaily. That's gremlin.com/sedaily to get your free demo of how Gremlin can help you prepare with resilience as a service. We have really framed the problem here, or the set of problems that are faced by consumers as well as within enterprises, because our examples have mostly been these products that are used by millions and millions of people, but this is also true internally. So if you're at a large enterprise and you have some internal application that somebody manages, you want the same kind of continuous release process. You want faster continuous releases. If you're building a giant piece of software that is, specifically for some domain, like the lumber industry, like let's say you work at an enterprise that builds software for the lumber industry, you have these same kinds of issues where you don't want to have to force a manual update for the lumber industry supply chain management software. You want to just have these small components, these very easy releases. So let's talk about the release process. So when we're talking about an individual release, every new software release produces a binary artifact. So the software gets built and the binary gets pushed back. In some cases, a developer might build the artifact on their own machine and then deploy it. In other cases, maybe they're building it on a build server that's dedicated to building the artifact and then rolling it out. Describe the different ways that an artifact gets built and rolled out.
Yeah, so it's basically, as you mentioned, for internal software, it is the same. Eventually, we do want to have the same idea of liquid software, but I think it's a little bit easier because we have the control of both parts of the release, right? We have the control of the software that we write and eventually of where the software gets deployed. And that means that we at least know, if not control, the state of the environment that we push our continuous updates to. The real tricky part is that we have no idea what's going on the device that we are sending our update to. And one of the examples of that I wanna give you is actually from Google. And a couple of years ago, before Google Home and all that, when they just started with their hardware journey and continuous update journey, they had this on-hub router. And I was on a business trip, and my wife called me and she's like, I came home and our kids are sitting in the dark. And I'm like, what, do we have like a power outage? And she's like, no, the internet went down. And I'm like, so what?
What?
And she's like, no, they didn't. They actually forgot that you can turn on the lights with the button.
Oh, no.
They went like, Alexa, lights on, and nothing happened. And they're like, okay, probably there are no lights. So, and the problem was the internet went down, not because my internet provider actually cut the internet, but because Google pushed an update to their own hub routers, and this update reset the router to factory settings. And so what's next? they cannot push a patch because the router is not connected to the internet anymore. So they sent an email apologizing and actually asked to reset the router and connect it back to the internet. But, for getting the email, you should be on the internet as well. Well, it's obviously wasn't that big of a problem, but it kind of shows that there is a lot to think about. Do you need to have a local rollback capabilities on the device? Because what the ideal situation would be in this case, that the router should diagnose itself after an update and realize that the connection is lost, and then roll back to previous snapshot of the state it was before the update, and then obviously the problem would be solved. There are a lot of moving parts there, and the less you have control over the other side, which gets the update, the harder it is. And when we live now in our continuous delivery and continuous deployment paradigm, we don't think about that enough. Every task is, okay, let's start from scratch. Let's imagine that there is a world there was nothing in before we start, which of course makes it easier to test, but actually provides a false picture of the reality, because in the reality there is something there.
So you raise a really interesting point with this whole on-hub incident and the idea of the on-device local rollback. Like, this is something that I wish my phone had, I wish my laptop had. But if we're talking about advice for software engineers, most of the engineers listening to this are building some kind of cloud service. They're deploying to the cloud, or maybe they're deploying to their on-prem servers that hopefully have something like Cloud Foundry or Kubernetes, where they can have a well-managed release process, something that is sort of like continuous delivery, or ideally it's continuous delivery, but at least they can control the rollout and the potential rollback of software. So this idea, like the example you gave with the on-hub, where you would want a local kind of reversion mechanism, isn't this just an edge case? Like, the kind of software that we're building typically, where we're just building for the cloud and we can roll back easily in the cloud, that seems like the general kind of case. Are you advocating for a whole new paradigm for people building and releasing software in the cloud as well, or is this more like a device, an IoT kind of issue that you're raising?
So that's a good question, and obviously it is more prominent in device and IoT. An example that I gave you is IoT, obviously, and for IoT I would say it's a must. But I also think it is true for other domains as well, because when we move into liquid software, when we move into continuous stream of updates into the device, the rollbacks will be frequent, because obviously you push so much, and some percentage of it, although you have this rigor testing, is actually might misbehave, because building a model of a real world into your testing is extremely hard, and there are corner cases, and then actually the rollback, the classical rollback that we are talking about now, and that's just take what we pushed previously and push it again, might be too big of an operation, because it involved actually selecting something stable based on the previous situation, which is not actually what you have on the device now, and actually sending it over a wire again. So instead of doing a rollback, what we actually call rollback now is a patch, is another update. A true rollback is just rolling back the exact environment on the device to a previous point of time. That's not the same as sending a new package, which is probably like the one that we sent today, to the device all over again. It's a little bit different.
Well, I really like the point you say about how difficult it is to test things in the real world, where you have so many different inputs. I worked at a trading company once, and if you build trading software, you really don't want to make a big mistake. Like, if you make a big mistake in building the trading software, maybe the traders think that they're trading in a certain way and the software is actually not doing what they think, and you end up losing a bunch of money and the company goes bankrupt, and that's really problematic. So you would think, okay, that's great. So we'll write tons of unit tests for, if I want to execute this kind of trade, we'll just write tons of unit tests and make sure that all the corner cases and whatnot work. That's actually really hard to do because a trade is, can have so many different parameters. You've got these different kinds of securities, and then maybe you want to set up a trade to work in a way where it only executes if this other trade actually executes. And there's so many different corner cases. And we did write unit tests, but it made me suspicious of the whole unit testing process. And so there was manual testing as well. So you had this combination of unit testing and manual testing. But even the premise that you could move to a world where you only have automated testing, where you're not testing in the wild, or you're not testing with a manual review process, I was very suspicious of that idea. And I remain very suspicious of it because our software deals with such a variety of inputs that it's just not possible to test in an automated fashion. So I like the idea of let's actually, because we're acknowledging that we can't test everything, let's really improve the rollback process.
Absolutely. And especially when we are talking about trading where every nanosecond counts because you can lose millions in those nanoseconds, releasing a patch, whether it's a new fix or it is something that we think that was deployed yesterday, is not fast enough. And this is where local rollback is so important. But going back to the fact that we cannot trust our unit tests in particular and automatic tests in general, this brings back the people that we just dismissed 20 minutes ago when we spoke about, okay, let's automate everything and there will be no manual QA. Actually, now we come back to the very, very rare, very important skills that those manual testers have. And this is unique understanding of the business domain and how this business domain can be tested. Does it mean that we want them to go and click through our user interfaces? I'd say we can put their unique knowledge into better usage, and that's in design of automatic tests in that way that we can build the trust that we spoke with. So those people, not only they are not going away, they actually getting promoted to actually much more important, much more sophisticated, and much more pleasant jobs of thinking about the design of testing instead of going through and clicking buttons.
Okay, so we have painted a kind of bleak picture for people who are listening who are, we set them up with this idealized world of liquid software that maybe they can get to someday. But then we've sort of dashed their fears by telling them all the ways in which this is, it's not possible to. First of all, it's you shouldn't be doing manual QA, but then we've just given a reason why you should be doing manual QA. But manual QA is a perfect example of something that completely slows down your release process. So you're at JFrog, which is a company that's focused on alleviating these kinds of problems. I've talked to countless continuous delivery software providers, countless monitoring companies, cloud providers, and there is all of this software that people are building that are alleviating different parts of this problem. I'm talking to somebody later today about serverless functions, and I've done a bunch of shows about that, so that kind of gets at the smaller composability. There are lots of different ways to tackle the small components of this refactoring, this movement towards liquid software. What are the things that JFrog is focused on?
So with our products, we truly believe that we move this vision of liquid software and continuous updates forward and implement it into reality. Since we kind of thought about this concept in the first place and talking the term of liquid software and continuous updates, it's obviously up to us now to prove that it's all doable, at least from the technical point of view, and we provide software to do that. Obviously, there is much more into it, and as we mentioned in the beginning, it starts with motivation, it starts with culture, it starts with actually wanting to do it, but we as JFrog can provide at least the technical part of it, and a bunch of our products support support the notion of liquid software and continuous updates, stuff like the JFrog Enterprise platform, in which you can actually build your software and then deploy it to Artifactory as the first step, start taking it through the pipeline of providing the quality and the security and making sure that this trust that we spoke about can be established, and then again in a secure and proven method deliver it to those end devices. But of course there are other, I would say, concepts, even in technical world, that need to come along in order to make a liquid software from something that you only see in a rare unicorn and you say, well, Google does it, but we probably can't, into something that every company can pick up and use. And that starting from being able to update and roll back the devices, either those are servers or IoT devices or laptop, with this continuous update. But at least the piping, the plumbing, I think we as JFrog deliver out of the box.
So your mention of the word device there, in the context of software that's built for improving the release process, I find that really interesting because when I think about devices, so first of all, if I'm writing software for Amazon Alexa Amazon Alexa, for example, I don't really control what's deployed to the device. I can make an Alexa skill, which is just a cloud service that the device can access. If I'm deploying software to an iPhone, my release process is totally gated by the Apple Store. So controlling the deployment of device to Apple or Google is sort of gated ultimately by Apple or Google. And then the software that I consume on a laptop, that's mostly software that I'm consuming through a cloud provider. I'm using my browser, I'm accessing it on a cloud provider. But IoT devices, I do see that as something where you're actually consuming software where the vendor has a whole lot of control over the deployment model to the device. Why that emphasis on the term device deployment? Do you have a lot of customers, or are you talking to a lot of people that are in IoT or that are deploying to actual servers, to actual devices?
I use the device as a high-level term of whatever machine we deploy stuff into. Server is a device, your laptop is a device, your phone is a device, and the IoT gateway in your home, whatever, SmartThings Hub or whatever, is a device as well. And continuous update can be more important or less important for each type of the device, but eventually they are all devices that we want to continuously update with liquid software, regardless of, is it your S3 Amazon server that you want to update and then people consume it through browser? Is it your application that people download on their computer, or it's an app on your phone, or it is a firmware of your smart home gadget? They are all devices.
Got it. Well, Baruch, it's been really great talking. I really appreciated your book. It's been a great read, and thanks for coming on Software Engineering Daily.
Thank you again for having me. I hope there is value in this concept that we try to explain. If you want to learn more, you can go to liquidsoftware.com or jfrog.com/SE Daily for Software Engineering Daily and learn more about it. There is a link to buy the book as well. And if you have any questions, feel free to contact me on Twitter at jbaruch.
Okay. Thanks, Baruch. I appreciate you coming on the show.
Thank you very much.
Continuous delivery frees up your developers to ship code independently of one another. And GoCD is an open source continuous delivery tool for doing just that. We've partnered with GoCD on content in the past, some great interviews, and today we're partnering to deliver some quick tips about modern continuous delivery. Today's tip is to provision your environments dynamically. You might not need a build server, a staging server, and a functional testing server running at all times. You could save money on your continuous delivery infrastructure by only spinning up these environments when you need them. To learn more about continuous delivery, to find tactics and strategies about continuous delivery, go to gocd.org/sedaily. You can also check out all of the shows we've done with the team around GoCD at softwareengineeringdaily.com and search for continuous delivery. GoCD has been a sponsor of Software Engineering Daily for more than 2 years, and we're proud to have their support and their partnership. If you're getting started with continuous delivery yourself, check out gocd.org/sedaily.
Wow.